Let's understand polynomial factors and graphs through this example. The first thing you need to understand are the features of polynomial factors and graphs. And I will start with the term zeros or the roots or x-intercepts, or you can say factors. These are the most important terms that you should be familiar with. And you need to understand that they are used interchangeably here and on the test. This is the most important thing. So polynomial functions on the SAT exam are usually shown in factored form. Now what's a factored form? For example, you have this equation. This is usually written like this in the exam. F of x equals x plus 3, x plus 1 and x minus 2. So these are all the factors of this equation. And what do I mean by zeros or roots or x-intercepts? So this means that at x equals minus 3 or at x equals minus 1 or at x equals 2, the graph is cutting the x-axis. So just remember this term. Zeros or roots or factors basically tell us the solution or the x-intercepts of the polynomial function. So simply, if a function is written like this, remember this form, f of x equals x minus a into x minus b into x minus c. These are the factors. And what are the roots? What are the solutions? What are the x-intercepts or zeros? They are equal to, you simply equate these factors to zeros and solve for the roots. So the roots are x equals a, x equals b and x equals c. These are the roots or the zeros. Please remember this. And if the roots are given to you and you are asked to form an equation, for example, let's say the roots are, let me change the color. The roots of a quadratic equation are x equals minus 2 and x equals 4. So what's the equation? You simply bring this number towards this side. It will become a factor. So the equation will become x minus 2 plus 2 into x minus 4. Just be careful with the sign. So this is your equation. So this is very important that you understand this concept. So to sum up, zeros or roots or x-intercepts are basically the points where the graph cuts the x-axis. That's the first thing you need to remember. Other than this, you should know how to find out the x-intercept. This is important. So how do you find the x-intercept? You basically equate y to 0. Similarly, if you are asked to find the y-intercept, you equate x to 0. These are a couple of things that you need to remember. Now let's have a look at a small example. What are the roots of this function? So we basically have the factors and now you know the drill. You equate the factors to 0 and you have your roots or x-intercepts or the solution. So the roots will be 2x minus 1 equals 0. You solve this, you will get x equals 1 by 2. You solve this factor, x minus 3 equals 0 and you have x equals 3 as the root. And finally, we have x plus 5 equals 0. What's the root? We have x equals minus 5. Similarly, if we were given these roots and were asked to form the equation, we could have worked backwards. So this will become x minus 1 by 2 into x minus 3 into x plus 5, which is basically the same thing. You take the LCM, you will get 2x minus 1. In this question, the roots are given to us. The real roots of the polynomial function p of x are minus 1, 3 and 8. Write a function that could be p of x. So p of x could be, we have our roots. What do? We work backwards. So basically, the roots are x equals minus 1, x equals 3 and x equals 8. We need to write them in factored form, which will become x plus 1, x minus 3 and x minus 8. finally the solution will look something like this. P of x, sorry, P of x, the function will look something like this. You multiply them and you will have your answer. X plus 1 into x minus 3 into x minus 8. This is our function. So basically, when you have the factored form, it's easy to identify the zeros or the x-intercepts of the graph, or even form an equation when the factors or the roots are given. But when a polynomial function is written in the standard form, this is called a standard form, it becomes a little tricky to identify the zeros. However, we can still determine the y-intercept from this equation and the end behavior of the graph. End behavior is very important. What do we call an end behavior? What exactly is the end behavior? It is basically just another term for what happens to the value of y, this, as x becomes very large in both positive and negative directions. So for example, if we have the highest power term as ax raised to power n, let's have a look at this term. Now if a is greater than 0, these are the things that you need to remember. If a is greater than 0, then y ultimately approaches positive infinity as x increases. If a is less than 0, I'll apply all these things on this graph as well. Let me just go through the points. If a is less than 0, then the opposite will happen. Then y ultimately approaches negative infinity as x increases. Thirdly, if n is odd, this power exponent is even, then the ends of the graph point in the same direction. This is one end, this is the other end. You see, these ends are not pointing in the same direction. That means that the n is odd, and we know in this scenario the n is odd. Let's examine this graph. So for this graph, what is the highest power term that we have? It is 1x cube. This is our highest power term. Let's examine this. So a is greater than 0. So y ultimately approaches positive infinity when x increases. You increase x, what will happen? This will approach positive infinity. If a is not less than 0, so I'll just skip this point. Now n in this scenario is odd. So that is why the ends point in the opposite direction. If it were even, let's say in the case of x squared, what happens? The ends are in the same direction. The ends are in the same direction. So these are the things that you need to remember. Let's now apply these things on a couple of questions. Let's evaluate this graph. So we have our function, that is minus 2x raised to power 4 minus 7x cubed plus 8x squared minus 10x minus 1. The graph of this function is also drawn. First of all, you need to look at the highest power term, which in this scenario is minus 2x raised to power 4. So you know a is negative. This is basically ax raised to power n. A is negative. A is minus 2. So when a is negative, what happens? Remember this rule? When a is negative, y ultimately approaches negative infinity as x increases. Look at this. So y will ultimately approach negative infinity as x increases. Secondly, look at the exponent. Remember, if this power, this n is even, what happens? The ends of the graph point in the same direction. Both the ends are pointing downwards. So see, this is something that you need to understand. Lastly, if x increases, what happens? We know that y ultimately approaches negative infinity. But what happens if x decreases? In this scenario, y will approach negative infinity again. In both the scenarios, y will approach negative infinity. So these are a couple of the things that you should be able to manipulate. Now let's have a look at a couple of past paper questions. This seems like an interesting question. Which of the following functions could represent the graph below in the xy plane where y equals p of x? Okay, so the first thing you need to understand is the ends point in the opposite direction. That means that the power has to be odd. We cannot have an even power. That means that a and c are gone. Now we're left with two options, that is b, x cube plus 6x squared plus 8x and x cube minus 6x squared plus 8x. So how do we know which sign should be there? This is where our zeros come in. This is where this will help you identify. Let's say this is 0. Just plug in some simple values. This is -1 and this is -2. So x equals, the roots are -2, x equals -1 and x equals 0. So if I have to form an equation from this, what do? I convert these into factors. And how do I do that? This will become x plus 2. This will become x plus 1. And this will become x. It will remain the same, x. So now we multiply these and we will have our equation. And it will look something like this. X plus 2 into x plus 1 into x. So you see, all the signs are positive in this scenario, which leaves us with option choice B. This basically tells us that one of the factors lie over here. One of the factors is positive. So that's how you manipulate the graph. The function p is a polynomial of t such that t minus 10, 22 minus t, t plus 10 and 20 plus t are all factors of p of t. Which of the following could be the graph of y equals p of t in the ty plane? Okay, so we are given 4 different factors. Let's evaluate these first. So t minus 10 equals 0. One of the roots is t equals 10. The second factor is 22 minus t equals 0, minus t equals minus 22, t equals 22. This is our second 0 or root or x-intercept. The third is this, t plus 10 equals 0. That leaves us with t equals minus 10. And lastly, we have, this is our fourth root, this is our third root, this is our second root, and this is our first root. We are given 4 different roots. So 20 plus t equals 0. So t equals minus 20. So if I sum this up, we have t equals 10, 22, minus 10 and minus 20. Now it will be easier for us to evaluate the graph. Okay, so we have 4 different roots. We can easily eliminate 2 option choices. I can clearly see graph B does not have 4 roots. Graph B has 1, 2 and 3 roots. So you can easily eliminate option choice B. Similarly, you can eliminate option choice D as well. This graph has 1 and 2 roots only. So this is also gone. Now, what do we do with A and C? Graph A has 1, 2, 3, 4, 5 roots. But we are only given 4 roots. The examiner is intelligent. He hasn't given us entire information, but he wants us to manipulate the graph through this information that's given to us. And in option choice C, we have 1, 2, 3, 4 and 5 roots. Now we need to look at the value of our roots. If you evaluate, that's why I solved these factors. If you see, we have 2 positive factors and 2 negative factors. That's only the case in option choice A. We have 2 negative factors here and 3 positive factors here. But in option choice C, all the factors are positive. You see, that is why we will go with option choice A. I hope you guys aren't bored because I have another very interesting question. Which of the following graphs in the xy plane have -3 and 5 as all of their distinct zeros for x is greater than or equal to -6 and less than or equal to 6? I've chosen this question because of this. In the last question, we didn't know that whether we had more factors or not. But in this question, the examiner is telling us that I am giving you all of their distinct factors or zeros, in between this range. So now let's evaluate the graphs. Let's evaluate graph 1. We have one x-intercept at -3. This is 1, 0. And another 0 or x-intercept is at 5. This makes sense. And these are the only 2 zeros in between this range. A definitely makes sense, graph 1. Let's have a look at graph 2. So we have 1, 0 at -3. This is fine. And we have another 0 at x equals 5. This is also fine. So in between this range, there are only two distinct zeros which are given to us, which are at -3 and 5. So this also makes sense. Let's look at graph 3. We have one 0 at x equals 5, but we don't have another 0 at x equals -3. So definitely this does not fulfill our condition. So our option choice is basically graph 1 and 2, which is option choice B. There you go.